So this is another interesting question in which we have a rod of mass m revolving about this axis with angular velocity omega. We need to find out the elongation of the rod where the density of the rod and the area of cross section of the rod is given. The Young's modulus can be assumed to be y. Now in this question, let us first find out the stress in the rod to find out the elongation. For finding out that, we must first analyze that the stress throughout the rod is not constant, because we will need different tension forces at different distances x so as to support the circular motion of rods of different lengths. Therefore, we know that the tension is not same throughout the length of the rod. Therefore, we need to first find out the tension in the rod as a function of x at a distance x. The remaining length of the rod is equal to L minus x. The total length of the rod can be taken to be L. For the remaining rod, the length is equal to L minus x. The mass of the remaining rod can be taken to be L minus x upon L into m, since the mass is uniformly distributed throughout the length of the rod. Now, the tension over here, let us break this part. This is the part with length L minus x, and this is revolving with angular velocity omega. The net resultant force towards the center of the circle is equal to T. This is equal to mass of the object into acceleration of the center of mass. The center of mass lies at a distance L minus x by 2 from this point. Therefore, the distance of center of mass of this object from the axis comes out to be equal to x plus L minus x upon 2. Therefore, this can be written, therefore, the acceleration of this will be equal to omega square into this distance, that is the distance of the center of mass from the center of the circle in which it is revolving. Therefore, omega square into 2x plus L minus x, that is equal to x plus L upon 2. Therefore, this is the acceleration of the center of mass. We know that the net external force on a body is equal to mass into acceleration of center of mass. So just writing the acceleration of center of mass over here suffices. Therefore, we write this equal to m square into x plus L upon 2. We know that m dash is equal to L minus x into m upon L. We substitute that here to get T is equal to m upon 2L into omega square into L minus x into L plus x, that is equal to L square minus x square. So first job is done. We get the tension in the rod as a function of the distance x from the axis. Now to find out the total elongation of the rod, since this tension is not constant throughout the rod, we have to integrate the extension in each of the small elements of the rod to find out the total elongation of the rod. Let us consider an element of thickness dx at a distance x from the axis. Now the tension here, as we know, will be equal to m omega square upon 2L into L square minus x square. Therefore, we can write the stress to be equal to T upon A, that is m omega square upon 2L into L square minus x square upon pi r square. This is the stress. We know that y is equal to stress upon strain, where strain is equal to change in configuration upon original configuration. Therefore, the strain can be written as stress upon y. Therefore, strain is equal to stress upon Young's modulus of the material of the wire. Now, we know that strain is equal to change in configuration upon original configuration. Now, the change in length of upon original length, that is dx, equal to this. Therefore, the small change in length can be written to be equal to m omega square upon 2 pi r square YL into L square minus X square into dx. This is the small change in length of this small element. Now, what we need to do is just integrate this change in length over all x. Therefore, the total elongation comes out to be equal to, so the total elongation comes out to be equal to integration 0 to L, so that we consider all dx elements from distance 0 to distance L, that is the length of the wire, m omega square upon 2 pi r square YL into L square minus X square dx. This is equal to m omega square upon 2 pi r square YL into integration of 0 to L square minus X square dx. This is equal to m omega square upon 2 pi r square YL into L cube minus L cube by 3, that is equal to 2L cube by 3. This becomes L square. So the final answer for the total elongation in the rod comes out to be equal to m omega square L square, the 2 gets cancelled also, 3 pi r square into y. So final answer for the total elongation of the rod comes out to be equal to m omega square L square upon 3 pi r square into y. The important thing you should have learned in this question is that whenever the stress is not same throughout the length of the rod, then you have to integrate the strain over each of the small elements of the rod. The important first part was finding out the tension in the rod as a function of x. We found out that by applying Newton's law on the remaining rod, but there is another method which you could have used to find out the tension. That is, you could have assumed a dx element at distance x. Let the tension at this end be T plus dt and this end be T. Therefore, dt could have been written as mass of this small element of thickness dx into omega square x. Now, this dm could have been written as total mass into dx upon L. Therefore, this would have been, this can be written as m dx upon L into omega square x. This is equal to m omega square x dx upon L. Now, this is the small change in tension at a distance x. That is the small increase in tension at the distance x. We need to find out the total increase in tension as we go from here to here. That is equal to integration L to x m omega square x dx upon L. This comes out to be equal to m omega square upon 2L into x square minus L square. Now, this is equal to m omega square upon 2L L square minus x square. This just tells you the direction, so you can forget this. Therefore, the value of tension at a distance x comes out to be the same as it came previously, that is m omega square upon 2L into L square minus x square. So, you can use this method also to find out the tension in the rod. So, final answer comes out to be m omega square L square upon 3 pi r square into y. Now, the value of m was equal to rho into pi r square into L. We substitute this here to get rho into pi r square gets cancelled, omega square L cube upon 3y. So, our final answer for the total elongation of the rod comes out to be rho into omega square into L cube upon 3 into y.